Hey everyone, welcome to this 10x live stream. Today I thought I'd take you through the preprocessor and tell you where I'm at and some of the things I've had to overcome. People who've been using 10x have been waiting very patiently for the preprocessor. It's been a long time in the coming. That's mainly because I've been working on other stuff, getting distracted by other things to do in 10x. But the last couple of weeks I've had some good time to actually get some work done on it. And preparing for this stream actually has been really useful for me because as I've been working on the preprocessor on and off for so long, it's hard to keep it all in my head. So I've had to go back through all the code, work out how it works, so I can hopefully explain it to you and make some sense of it. So I hope you find that interesting and enjoyable. So good evening. Right, so where do we start? Talk about includes. Okay, I will talk about includes. Let's open up 10x project. So, I mean, I've talked about the parser before in some of my earlier streams, but one thing you need to understand about the preprocessor is that it doesn't actually, about the parser currently without the preprocessor, it doesn't do anything with includes at all. Literally all it does is it goes through the entire code base and every file and just scans every file, parses it, and treats the whole project as if it's one whole rather than the C++ approach where you treat each file as a whole. So what you should do when you're writing a compiler or a parser is take each include, obviously expand that include and insert the code that's in that include in the CPP file, obviously, and do that recursively for all the other includes. And as I'm sure some of you are aware, that can get pretty big, especially if you're including Windows header files or STL or anything. You can easily have files that are tens of thousands of lines long, even for a small CPP file. So I took the decision not to do that for 10x for a number of reasons. Because A, I want it to always be fast, the parsing, and B, I want it to work so that when you're typing code, it updates immediately. And if you've got, say, a 10,000 line file and all it includes to parse each time you change something, it can get pretty complex and pretty slow. So I just ignore all the includes and just parse each file individually and then put it all together as in a linker. And that's the current state of the parser. Now I know that's wrong, and I know it won't work for some things. Some things it will break because you really expect if you're including a certain include, it will find the class in that include rather than a different include. So there are times when it will break, I admit that, but I made the decision consciously to keep the parser fast and somewhat manageable because it's a very complex thing. So anyway, that aside, for the preprocessor, I decided that I would treat includes properly as they're supposed to be treated. So that makes it a little bit complex. And the reason I did that is because you can do stuff, obviously, like, so you can see this. Enable my thing, and then include the header where enable my thing will enable something or not. And that's a fairly common thing. So I do want the preprocessor to follow includes and bring in, say if in the header you've got a define and you include this header, you expect that my define obviously to come from that header, and if it isn't included in anywhere, you don't want it to be defined. So there are lots of things that it's more important for the preprocessor, in my opinion, to have proper include chasing. So that was one of the complexities of it. And also, the other thing is, it's not like writing a C++ compiler because, as I said, you have to cope with updating as the user types. So ideally, you just want to, if I change this line, you just want to reparse that line and not the whole file. So that adds extra complexity in there as well. So let's go back to my notes. So as I've probably mentioned before, there are currently, well, before the preprocessor, there are only two parses. So this and this have been added. So what it looked like before was this. Parse 1 reads the file off disk, tokenizes it, parses it, and the parser parses the classes, structures, functions, variables, etc. And all the scopes, curly braces and scopes and stuff. And then the second parse goes through and does what I call a def parse, and that's resolving keywords. So any keyword it finds, such as this, it will essentially do a go-to definition on it to find out what it is, and it finds out it's an int or whatever. And it will do that for every single file, for every single keyword. And that's how we get the syntax highlighting as well. So that's how it works currently. Very simple, just two parses. So for the preprocessor, I added a step in the read file, which I'll explain in a second, and then in parse 2 is when it does the preprocess, and it does that before the tokenize. Well, actually, that's not quite true. The tokenize does come first, and then it preprocesses it and retokenizes any lines that have changed, and then it does the parse as normal and then the parsed defs. So when I say a parse on it, what that means is when you see it doing the initial parse and the progress bar, top right hand corner, one parse means it's gone through all of the files. And then in the second parse, it doesn't do that until all of the files have gone through the first parse. So I need to know that I've got all of the preprocessor lines, for example, before I start running the preprocessor and then parsing it. So I needed to add in this extra pass, which is a little bit complex. Because that's what makes the preprocessor difficult, is because it's got to fit within the current parser, the way I've done it. Because in a way, the preprocessor is not that complicated. It's just text substitution, really, and it's a very simple language. But it's just a little bit fiddly. So yeah, what does this line do? The get preprocessor lines. So what I do is, as I said, I want to actually use the include lines. Let's go back to example. So I want to use the include. So when you include something, what it does, in this first pass for every file, after it reads it off disk, it'll collect all the preprocessor lines. So for example, if it's parsing core.h, it'll have a file of just the preprocessor lines and nothing else. So it won't actually include any of the code, it won't include any of that stuff. It'll literally just be the preprocessor lines. So if you can imagine, it's just like this. See, comments won't be there, anything else gets deleted. It's literally just all this. So none of that would be there. That would be there. So it's like a very simple file of just the preprocessor lines. Undo that. So that's in the first pass. And the reason I do that is because to make it faster parsing a file. So when say I'm parsing this file and it includes core.h, I don't have to open up core.h, which might be huge, and scan through and include everything in that file when I'm compiling this file. I can just say, okay, that preprocessor list of lines you had, I'll just grab that and then create a whole big list of all the define the preprocessor lines from all of these files. So I've got one massive file, just preprocessor stuff. And that makes it very fast to update and parse. So that's on the first step. So in Parse 2, I tokenize it as I normally do. And then I run the preprocessor, which does all the substitutions. And any line that has substitutions, it will then retokenize that line before it does the proper parse. So the parse is working obviously with the preprocessed files. And I wonder if it's worth showing you that code. Let's show you an example first before I get into that. Let's get rid of that. So let's show you this. Yeah, let's talk about the substitutions. I can never say that word. Let's get rid of that. Someone's just asked me, do I have plans to support other languages? Yep, definitely, given time. So I'm working on C++ first because A, it's the one I know the best, and B, it's the hardest language, I think, to parse. C# shouldn't be too bad. And then I go on to other languages such as Python and stuff. So yeah, longer term, definitely want to support other languages. I'm hoping I can reuse a lot of the parser stuff I've written. It needs a big old refactor, but a lot of it can be reused. The actual parsing of the classes and structs and functions and stuff is not that complex, surprisingly enough. So I'm hoping it won't take too long to actually extend it like that. So this example here, so let's see if I've got this new pen, I can highlight stuff. So if I've got this define called test, which defines to member func1. So it indirects off class 1. This gets substituted member func1, obviously, and then it calls member func2. Now, the important thing with the substitutions is that, as you know, the parser is working with. So let's just to make it easier to talk about. So this is the line that the parser is actually parsing, which is good. That's as we want it. And all the syntax highlighting is going to be on this line as well. Actually, we don't need to comment it. So this is what the parser sees. This is what the syntax highlighting is. But the line we're showing to the user is this line. So when I make a substitution with test, I have to know that this bit before. So let's see if I can. So these two bits match up, and I have to know that this bit matches up as well. Okay, so I know that this range was mapped to this range. And then I get the correct syntax highlighting after the preprocessor is run. And that's a tricky little problem for a number of reasons. The other reason I need it is because when you do go to definition on this, sorry, no, that's not a good example. I'll show you that in a minute. But anyway, you get the idea. It has to, when you make a substitution, it has to know where it came from in the preprocessed line so that all the syntax highlighting still matches. And in this case, it's really simple. You've just got a bit at the beginning, a bit at the end. But obviously it gets a lot more complex when you've got macros inside of macros, etc., and multiple macros per line, macros defined in terms of other macros, and as you can imagine, it gets complex pretty quickly. The other thing I mentioned is that I've now got, let's get rid of that, I've now got pop-ups, so if you hover over something, it will show you where that the symbol is defined and the preprocessed line as well. So here it's showing us that it's got member func1 in there instead of test. I kind of needed that as an easy way to test the preprocessor and what's actually doing what I wanted it to do, which is good. So yeah, I hope you find that useful. I'll get syntax highlighting in there at some point. Let's move on to another example because I wanted to show you. Yeah. So the other thing about substitutions is you need to cope with obviously arguments, macro arguments. So in this case, a really simple example in test, and it just does AB. So this, this resolves to, as we can see, in test. What I've spent probably far too long trying to get working, because it's not actually that important, but it's just something I wanted to do, is it knows where the macro arguments are substituted. So that's what it resolves to. And so this line, that's what it resolves to. And I want to know that when I do go to definition on here, it will go to this definition here. Okay, so whenever I substitute an argument, I always keep track of where it came from in the original line. And that's nice because I get proper syntax highlighting in the line that's visible, and the go to definition will actually work on template arguments. That's what turned into a very complex thing, as I was saying, because you can have obviously macro arguments defined in terms of other macro arguments. I think I had an example in the next one. Yeah. So we've got two macros here, test1 and test2. Test2 just resolves the argument to itself, just as an example. So you've got test1. So it first resolves test1 and puts in a equals 0. And then it will obviously resolve A to be test2, and then resolves test2 to be the argument, just the argument, which is test. And the nice thing is, so it's first A equals 0, and then it resolves it to that, obviously a semicolon at the end. And then obviously it will resolve it to, sorry. I mean, this is all obvious. I know I'm not telling you anything you don't know. But what we need to know is that this is at this index, came from that range, and this came from that range. So it always knows where each bit of the fully resolved line came from and where it is in the original thing. So if I do go to definition on here, it will know to go to here when it goes in the result. So hopefully that gives you an idea of some of the sort of subtleties of it and the complexity. I don't know why that's not highlighted. That should be highlighted as a macro. I'll have to have a look at that at some point. But also it has to work out, it has to remember where the actual macro is, so I can go to definition on here, and it goes to there, even though in the line the parser is dealing with, test1 doesn't exist, because obviously it's gone. But I still want to be able to go to definition on that for it to work. So there's lots of little things that obviously the preprocessor and substitutions are pretty easy, but to keep track of everything so that go to definition works and the syntax highlighting still works is a little bit of a challenge. Oh yeah, a bug I found just running the preprocessor on my code base is actually an external library that found this. It's not something I've ever thought about before, but you can actually have what are potentially recursive macros. So here I've just got a function called test, uppercase in this case, and a macro called test, which is fine. And the code was actually something like if a, which is the argument, then call the function. But the macro is called the same thing as the function. Okay, which in a way I looked at it and thought that shouldn't work, but yeah, it does. And obviously what happens is when it's resolving the arguments, because what I do is as I parse it, I parse it multiple times. So this will first obviously go to get resolved to this line, and then I run the preprocessor again on the same line, because obviously you can have macros that are recursive, like I was saying earlier. So you do run the preprocessor once and it resolves to another macro, so you've got to run it again, etc., until it's stopped resolving macros. And obviously that's going to go into an infinite loop, because it's just going to find test again and think, oh, that's a macro, I know that, I'll resolve it. And it keeps resolving that again and again and again, adding to the line. And as you can see, the parser has just basically stopped working because it's gone into an infinite loop, and it's probably chewing up memory right now. And actually I've just done go to definition and now it's locked up. So that's the kind of bug I have to deal with, the kind of lesser used aspects of macros, which people do kind of use or abuse sometimes. And obviously 10x has got to cope with anything that gets thrown at it. So what I need to do is break it down so that when it parses the line, it does it recursively, and I can actually detect any infinite recursion and stop it. So say, no, you've already passed test once, don't do it again, obviously. So yeah, exactly. C++ keeps surprising us. It's craziness. Yeah, I mean, in a way, I've realised that the preprocessor is often abused even more than the C++ language, because you can do some really crazy stuff with it. Don't even get me started on template metaprogramming. But anyway, as long as 10x doesn't obviously crash, that's the main thing, and as long as it coats with 99% of any cases that are thrown at it, it's probably going to be good enough. Like I was saying before, I'm not writing a C++ parser because I want to get it done in less than 10 or 20 years. So I am taking shortcuts, but hopefully it will work well enough to cover almost all cases, and it will be rock solid and fast. That's my goal. Rather than being absolutely complete, I want to make something that's useful and you can rely on. So anyway, that's locked up now, so I need to restart. Let's see what else I've got on my notes. Oh yeah, I'll do a quick run through conditionals. They're working now, so hopefully let's just make this a bit bigger for you. So you can see it's grayed it out because it's defined out, and changing it changes that. Oh, that's the other thing I probably should mention, is that one of the things to keep it fast as you're typing is, obviously, like I said, when you change a line, it just currently reparses that line, or any subsequent lines it then needs to reparse. And that's what keeps it very fast. Now, obviously, with defines, I can change a define in a header, and it's going to change loads of stuff, or not change loads of stuff. And how do I know that? So that's a tricky problem to solve. And the way I've done it is I keep track of what files are included from what. So I know this includes quicktest.h, QuickTest.h is empty at the moment. But QuickTest.h knows that's being included by QuickTest.cpp. So if I have a define in here, then, and I change this define, I know that I potentially got to reparse any CPP that includes that header, which is okay, that's reasonable, but that could mean reparsing half the code base. So what I do is, as I said, if you remember I said I create a list of just the preprocessor lines. What I do is I run that through the preprocessor and see if anything has changed. If it has changed, and say this bit of code gets enabled, then I'll just reparse the entire file. But if it hasn't changed, I know I don't need to reparse anything, which is hopefully going to limit the amount of full reparses it has to do every time you change your define. So the other thing I was going to mention is, I said it after the read file, it gets the list of preprocessor lines. That's just all the lines that are preprocessor. I actually resolve the conditionals at that point, or do I? I've tried so many different ways of doing this. I don't do that. I tried it, but it obviously didn't work. But what I'm saying is I run the preprocessor just on the preprocessor conditionals before the full preprocess of the entire file. So I just run through all the conditionals. I resolve any macros. So here, obviously, you can see it's just this would be resolved to hashif1 in this case. And I can store that off, so I don't have to keep re-evaluating that at all. So I've got a list of all the conditional lines in the entire file, and I just store off. I first resolve them with the preprocessor, and then store off the results of it, and I know which bits of code are defined in and which bits are defined out. And again, that keeps it fast, so I don't have to keep re-resolving the entire file when you just change one line. So it also supports, obviously, else all going well. Yes, it's good. And it supports simple yeah. So one or the other, but not both. That works. Yeah. And it supports, hopefully this is still working. Oops. So one or the other. So it does the brackets, and it just does that recursively, evaluating each conditional at a time. One thing I just realised the other day is I've forgotten about the other conditionals, such as greater than, less than, equals, etc. So I'll add those in, but that shouldn't be too much of a job. And obviously it supports elif and all the rest as well. So I think that's that. Yeah, I think that's all I was going to say about that. Let's see if I have any questions. Any provisions for defines outside the codebase, for example, calling the compiler of dsymbol or Visual Studio preprocessed defines? Yeah, it should. I already, when I, because I've done this for the include paths and things like that, so that I can pick up where includes are coming from. So I already scan, for example, the Visual Studio project files for all the project variables. So I have actually got a list of defines for the project for each config and platform for Visual Studio projects. So that should be easy enough just to plug in and say these are globally defined. I will be adding a, as you know, you can go to project settings, and at the moment you can set, that's not a good example, but let's open up Visual Studio project. So you can set additional and include paths, so they can pick up where includes are, etc. And I'll be adding in a defines here so that you can manually override. If 10x isn't picking up the defines from the project files for whatever reason, you can manually override and add them in here. Another thing I was thinking of doing to make it easier is if you've got, say, for example, this, and 10x hasn't resolved it for whatever reason, you'll be able to right-click on it and say, I know this is true in this configuration, and so it's true. And that'll automatically add it to the settings for this config and add a define for it, just to make it easier, because I'm never going to be able to pick up probably every way projects are built or custom build scripts and everything. But if 10x can't get it right, then at least you'll be able to easily override it and add it in yourself. I may be able to do stuff for custom build scripts. Maybe I could expose it to Python actually, and add a way for you to tell 10x what things are defined if you're using a custom build. A question, I haven't let it loose on Unreal yet. I'm terrified of doing that, but obviously I will at some point. That's going to be the real test. And actually that's going to be another test because Unreal has its own way of building, an own way of setting the preprocessor defines. So that's going to be tricky to work out what defines should be globally defined or not. So that's why I was saying, for now at least, I'm going to allow a way for you to manually override it until I work out how all that's done. But yeah, Unreal is going to be the ultimate test of the preprocessor. So at the moment I've just been writing very, very simple unit tests, like I've been showing you in the the tests I've just been showing you, really simple ones like this. And I built up, 10 or 20 or 30 tests now, I think, so that I know that when I fix one thing, I'm not breaking another thing. But I haven't actually let it loose much on anything. I've just started running it on the 10x code base itself, and it's coping with my code pretty well because I don't use the preprocessor that much. But I've got external libraries such as Python and curl and things, and they do use preprocessor more in slightly weird ways, which is where I picked up that bug I told you about earlier, the recursive bug. So yeah, I'm just going to, over the next week or two, I'm just going to be gradually testing it on more and more code bases to try and pick up all the horrible edge cases that I can find, and hopefully make it, at the very least, make it robust so that it doesn't crash or lock up or anything, and then start working on supporting any things that I've missed, because I'm sure I've missed quite a few. But this is these are the tests I've written so far, and they're just testing things like simple substitutions, macro arguments, recursive macro arguments, all the kind of edge cases I can think of, conditionals, etc., and making sure the include chasing is working correctly, so that if I include a file that includes another include, etc., then it does actually get picked up properly. And obviously that's going to be stressed a lot more when I use it on proper code bases. But yeah, so far it's all working pretty well. If I run the test, I had to comment out one test, so that's not working properly yet. But if I just run that, it should all going well. Not that you can see what's going on because it's too fast. But basically it's just running through every test in turn, making some changes or doing go to definition on a keyword and checking that it ends up in the right place. Actually, if I slow it down a bit, let's put a sleep in there. 400, no, 400. So you can see it here, it's just doing go to definition and checking that it ends up in the right place. And it's just using various different things like defines, defines in headers, and I also do editing of code, so I make sure that when I change a define that the right code is defined in or defined out, with all the conditionals and stuff like that. So yeah, that's what I've been working on so far. And as I said, apart from the missing the some of the less than, greater than, equals conditionals, I think it's feature complete, the preprocessor, apart from, like I said, some weird edge cases. So I'm hoping it's just a case of testing on as much code as I can, and then I'll let it out to the world and see what happens. I'm hoping that maybe end of next week, if I get a full solid week with no interruptions, then I think I may be able to get a build out to you guys and see how it works with your code bases. So yeah, that's pretty exciting because I think it's really going to improve the parsing, especially for code bases like Unreal, which rely quite heavily on the preprocessor. At the moment it misses quite a lot of stuff, which is pretty annoying. So it's going to get a load, even if it's not 100% complete, it's going to get a load more coverage of the parser and hopefully be more useful. Right, so I think that's probably all I've got to say on the preprocessor at the moment. I'll be happy to take you through the code, but it would be quite complex and difficult to explain currently. That's probably the best I can do at the moment, but I'm happy to do a deeper dive at some point if people are interested. So yeah, do let me know if you've got any more questions in the chat. I mean, you ask me general questions on 10x, not just about the preprocessor. There was one other thing I was going to mention. What was that? Shut down timeout crashes. Yeah, now I'm getting a few crashes coming through which happen like a couple of minutes after you've shut down 10x. And the reason that happens is, at the moment, the parser isn't very good at dealing with external changes. So if you have 10x open, or even if you don't have it open, but if you say do a sync or change branches or something and it changes hundreds of files in your code base, 10x will treat those changes as incremental changes as if you just type them in. And at the moment it gets itself into a bit of a crazy situation where it starts trying to incrementally reparse the entire code base, and that can take ages at the moment. There are some things that I know I can improve with that, so it's not something I'm worried about, but it can just get itself into a complete state, and the parser, you can carry on working in 10x, but the parser will be sitting there in the background just crazily churning through everything. So if that happens to you, best thing to do is just close down 10x, delete the parser cache, and then start up again, and it will reparse everything and then be fine. So it's fine if you delete the cache, it will just reparse everything from scratch, and then it's fine. It's only when it tries to do incremental updates on big changes. So that's something I know about, and I'm going to tackle that once I've done the preprocessor. But what happens is, it takes a long time to shut down. So you shut down 10x, it'll disappear, but it'll still be there in the background. You can see it in Task Manager. And I put a timeout of something like 2 minutes, and if
if it doesn't shut down within 2 minutes, it'll create a crash dump so that I can see why it hasn't shut down, which is really useful for me. And that's how I found out what's happening. So yeah, don't be worried if that does happen. And I will hopefully be fixing it soon. Right, so yeah, I think that's everything. So I'll probably do another stream in a couple of weeks, and hopefully by that time the preprocessor will be in and being used by people, so you can tell me how you're getting on. But yeah, thanks for watching, and I'll see you again soon. Appreciate it.